Hello, friends. My name is Miss Acevedo, and I'm a volunteer with USC JEP Young Scientists Program. And this week, I'm going to be demonstrating ocean currents for you. So if you could see my turtle here, we're on Earth and Human Activity number 2, week 2. So we're going to be learning about ocean currents. So today, you will be able to describe how ocean currents move using a model ocean. So that means we're not going to use the real ocean today. We're going to use an ocean, a sample or a model of an ocean that I made in my learning space, and you're going to learn how to make your own model ocean in your learning space today. So my first question for you is, have you ever seen the ocean? And have you ever wondered why and how the ocean water moves? So in a moment, we're going to look at a video of the ocean. So let's take a look at moving ocean water. And we're going to look, have you ever wondered why and how ocean water moves? So I'm going to go ahead and play my video here. Nice. And I don't know if you saw that, but what I saw was the ocean moving. So when we go and when we see the ocean, it does not stand still like our bathtub water. No, our ocean moves. So what we're going to do today is we're going to investigate how and why our ocean water moves. So today we're going to be using an ocean habitat model. And in a moment, you'll see the habitat model that I made. And I want you to think to yourself, what do you notice? That means something that you see. And what do you wonder? That means something you want to find out. So take a moment and think about, after you look at the model, what do you notice and what do you wonder? So let's look closely at this model ocean. Let's remember that red water is hot water and blue water is cold water. And you're going to tell me what you noticed and what you wonder. So let's get started. That is happening in our model ocean. Give me 1 second, friends. There we go. Hello, friends, and welcome to a new science experiment. Last week, we learned about ocean habitats, right? That's a place where sea animals live. And we learned last week that there's 4 different animals that live in an ocean habitat. We learned about sea turtles, fish, crabs, and dolphin. This week, what we're going to learn about is ocean currents. So what we're going to do is we're going to make a model of the ocean, and I'm going to teach you how to do that with materials from your home. So here, you will see that I have a model ocean. I filled out a tub with blue water. This water is cold water. And what I'm going to do is I'm going to add some extra ice cubes to make sure that this water is super cold. So I'm going to go ahead and add that in. There we go. And as you can see in my model ocean here, I have my sea turtle, I have a dolphin, and I have a crab. So that's our sea animals that we're going to be looking at. And this week, we're going to see how ocean currents form. So I'm going to go ahead and take some hot water. This is hot water here. What I'm going to do is I'm going to take my hot water, which is red, and move it into my tub of cold water. And we can see that it's very cold now because the ice has begun to melt. So we're going to go ahead and pour it in and see what happens. Nice. So go ahead and observe, what do you see that is happening in our model ocean? Nice. So we just saw that we had cold water and warm water and what happened when they came together. So let's continue to learn. So we're going to zoom in closer and look at what happened in our model habitat. So we know that the red water is hot water and blue water is cold water. And we saw some movement here, right? I see the red water's going in one direction, the blue water's going in a different direction, and I saw my ice cubes were moving, I saw my animals were moving. So we need to figure out, why did this happen? And that's your job to figure out too. You have to think about why it happened, and you're gonna answer, I think this happened because, at the end of the video. So we're gonna go ahead and keep going. So let's review some vocabulary today. We have 3 brand new words today. Our first word is current, and that means water moving in one direction in a larger body of water. So here's our big ocean, and now I see this current right here where my turtle is going. It is moving in a different direction. It's kind of like a small river. That's a current, a small river in the big ocean. Our next vocabulary word here is wind. And you can see my little friend here. He's moving because of the wind, and you can see the wind moving the water. Well, wind is the natural movement of air, and I'm sure many of us have felt wind before. Give me 1 second, friends. I'm going to try to make this a little bit bigger so we can see it. Let's try that. Perfect. So we know that wind is the natural movement of air. And our last word today is temperature. And I'm not talking about the temperature on your forehead. No, no, no. I'm talking about the degree or intensity of heat, right? Not your body heat, but the heat around you. And we see when the temperature moves higher up here, that means it's really hot. And when the temperature comes down here, that means it's cooler, right? So we have our 3 vocabulary words today: current, wind, and temperature. Let's move on. So many animals live in the ocean. They need the ocean to survive. The ocean covers about 70% of Earth's surface, but the water doesn't stay in one place. So we can see right here where my turtle is. Here's our world. It is 70% ocean. That means there's lots of water around us, and you can see the water here. And you also see those white arrows, and they're moving. You can notice that those arrows are moving water. That means the water keeps moving left, it moves right. And if you notice their pattern, they move in circles. Wow. The ocean water is constantly moving around, and it is moved by currents, that vocabulary word, which are like small rivers in the ocean. So here we see my turtle moving up the current. And we see here that currents move in circular patterns, right? We see them right here. They move in circular patterns, and they go left to right. Now, what are some things that might change how water moves? Well, currents could be caused by the wind, right? If you blow on water, it moves. Just like if you blow on water in your bathtub, it moves. And in the ocean, the natural wind from the outside world is moving the ocean water. But wind alone does not move the ocean. That would take a lot of wind to move all that water. Wind is just one way our ocean water moves. The next thing that helps our ocean move is currents can also be caused by temperature, right? So we know that temperature means if something's hot or if something's cold. So let's zoom in closer. We saw that the red water was hot, and the blue water was cold. And when there's two different temperatures, it causes a current, a small river, moving water. And we can see that here. We know that currents move in circular motions. And we see that here. If I take my turtle and we move with the water, we see that the water is circling and it's forming a current. It's moving. And that's because we put the red water, the hot water, and the blue water, the cold water together. So when water is hot, it will rise to the top of the water because it is less dense than cold water. That means it's lighter. Hot water is lighter. When water is cold, it will sink down to the bottom of the ocean because it is more dense, meaning that it's heavier. And we can see our picture here. We have hot water moving up because it's less dense, and cold water moving down because it's more dense. The different temperatures and density will make different pathways for the water to move around in. So we see here, the water is moving by itself because of the temperature, not just the wind, but temperature. Now, why are currents, why is moving water important to sea animals? Well, currents are important to sea animals because currents are very important to sea animals because the water pushes food towards the animals in the sea, and it helps the fish move from place to place in the ocean. And not just fish, other animals too. Sharks, whales, dolphins, all these different animals need food to eat, and the water pushes the food towards the animals, but the animals also need to travel and move from place to find food or to live in a comfy place, right? So the water helps these ocean animals move. Animals need moving currents, need moving water. So now it's your turn. I would like you to make your own model ocean. And here are some materials, and here's a picture to show you how to use the materials. So these are the materials you're gonna need. You're gonna need a clear tub of water. You're gonna need some cold water. I put ice cubes, but you can put your water in the refrigerator and make it cold. And then hot water. You can just use hot water from the sink. Red food coloring for the hot water, blue food coloring for the cold water, so we can see that they're different, and sea animals. I printed pictures and threw them in there, but if you have real sea animal toys, you can throw them in there as well. And you will see, you will create your ocean model. But this is very important. If you are going to be using that hot water, you need to make sure an adult is there to help you, right? Because you don't want to burn yourself. So to make your model ocean, you're gonna pour some hot water, red water, into a tub of cold blue water. And you're gonna watch how the currents form, right? Because we learned that hot water and cold water move because they have different densities. Then after you create your model ocean, I want you to show your learning in a drawing. So you would need a piece of paper and some crayons to show your learning. You're gonna draw and label the ocean currents using that vocabulary word currents on your paper, and you're gonna draw some sea animals. So you know that a current is a river of water, as we saw in our experiment, and that what you're gonna try at home today is you're gonna make your own currents, these small rivers in a bigger ocean, right? And remember, hot water goes to the top and cold water goes to the bottom, and you're gonna see that in your experiment today. Now here's my example. I drew and labeled. So here is my ocean, and I labeled cold water blue. And here's my hot water, and I labeled that and colored it red. and I drew my sea animals, fish and octopus. But what I also drew was my current, because I saw how ocean water moves when there's wind on it. And when hot water and cold water come together, they create currents, small rivers. So I hope that you all have much success with your model ocean. And if you need to remind yourself how to make the ocean, feel free to rewind the video and go to the beginning, and you can see how I did mine and see if you can get yours to make currents as well. Now, before we go, I want to put a spotlight to a scientist, right? Because every week we learn about a new scientist. This week, we're going to be learning about Ashanti Johnson. And here she is here with her nice big smile. Ashanti Johnson is a chemical oceanographer. That means she studies the natural and man-made chemicals in the ocean, because there's chemicals in the ocean, right? And here's an example. They would study the ocean with all this technology, and they'll see how these chemicals change the ocean. So Ashanti is the first African-American female chemical oceanographer in our entire country. Her research focuses on studying how the past and how past events have affected our oceans. That means changes our oceans. When chemicals get into our ocean, that means it's different. In 2010, she earned the Presidential Award for Excellence in Science, Mathematics, and Engineering. That's a big deal. And in the 5th grade, she spent a day discussing the oceans with a female marine biology graduate student. That means someone in college. She was 10 years old and she got to spend the day with a college student. And that is the day when she realized she wanted to study the ocean just like the person she spent her day with. She shares her interest in the oceans with children, teachers, community leaders, and college students. So that means she learns about the ocean, and then she comes to schools and our communities and she teaches about the ocean. So she loves to share what she knows in her head. And she is Ashanti Johnson, and she is a very famous chemical oceanographer. So I'm going to go ahead and sign off today. I hope you learned a lot about ocean currents, and I can't wait to see you next week. And we can try out new experiments next week. Have a wonderful day. Bye, friends.